Welcome to the second video on the topic of promises and async await in the JavaScript function series. The last video taught us about synchronous and asynchronous callbacks and how a nested async callback can lead to a callback hell. In this video, we will learn about JavaScript feature called promise that helps us to write cleaner, easier to understand asynchronous code. It also provides a way to handle the final result, whether the execution of the asynchronous code is a success or a failure. In this video, we will start with the understanding the concept of a promise. Then we will learn about three different states of a promise object and what they mean. This will be followed by understanding the working of a promise and how we write this code and make a synchronous program easily readable and manageable. We will learn about promise consumers, promise chaining, and error handling in this as well. Finally, we will implement an asynchronous code that reads data from 3 files and writes the output to a 4th file using promise. And we'll compare this code against the callback style implementation. After watching this video, you will learn how to handle asynchronous code in JavaScript without losing your mind. This will help you write more intuitive and maintainable code, and you will understand why this concept is a must-know for any modern JavaScript developer. So here we start with understanding the concept of a promise. So a promise is an object that represents the eventual completion or failure of an asynchronous operation. And it is a placeholder for a value that will be available sometime in future. You can think of a promise as a promise we make to someone. We either fulfill the promise or we do not, but we do not know when we make the promise. Now in JavaScript, it is all about the code. It executes successfully or it fails, but we do not know immediately how the result will be. Now we will understand the 3 different states of a promise. The first one is pending. So this is an object's initial state, and this indicates that an asynchronous operation is in progress. And depending on the operation's result, it either changes to fulfilled or rejected. The fulfilled state indicates that the asynchronous operation is a success, and the rejected state indicates that an asynchronous operation is a failure. Note, once a promise changes its state from pending to fulfilled or rejected, it cannot be changed back again, and it is said to be resolved or settled. Now we will understand the working of a promise. A promise connects 2 parts of the program, the asynchronous code, which we call the executor function, and the other part of the code which depends on the completion of this asynchronous code called consumers. Let's go in more details with some pseudocode. Now to create a promise, you have to use a promise constructor. Now this constructor accepts a callback function that executes the asynchronous operation. This callback function is called executor function. You can give any name to this function, and this constructor function returns a new promise object. The executor function should accept 2 arguments. These arguments are again callbacks that JavaScript provides. The names are resolve and reject, and these 2 are conventions as well. You can give any name to these functions. Once the asynchronous code completes its execution, the executor function must call resolve when the execution succeeds or call reject when it fails. The resolve function is called with the value, which is the data passed to the code waiting for the completion of the asynchronous code. When resolve is called, the state of the promise changes from pending to fulfilled. The reject function is called with an error which the error handling mechanism manages. And when reject is called, the state of a promise changes from pending to rejected. Before we proceed, I suggest you to take a short break and review the working of the promises and view this section again. Now we will learn about the consumers of promise. So once a promise is resolved, this information is available to the consumers, and these are .then, .catch, and .finally. So when a promise is fulfilled, we call the .then method of the promise object that connects a promise with the consumer. The .then method takes 2 parameters. Both are optional callback functions, and these are onFulfilled and onRejected. These function names again are conventions, and you can any function name you like. This .then method returns a new promise which is then passed on to the next consumer. When we have one or more .then or .catch methods, it is called a promise chain. Let's get more clarity of consumers by looking at the pseudocode. The .then method receives handler function as a callback. The handler function can either be a normal or a async function. So when a handler function is a normal function with a return statement, the returned value is wrapped as a promise object and passed on to the next consumer in the promise chain. When the handler function executes asynchronous code, it returns a promise object. The last statement of console.log, the argument input data receives the value passed as a parameter to the resolve function of the executor function. Now it's time to implement one example. For this, I wrote three functions: task A, task B, and task C. Now each function executes a callback after a delay of 1 second. And the intention is to complete these tasks in a sequence after a gap of 1 second each. And the requirement is to print the data passed to these functions as one single string. Now, since each task takes at least 1 second, the code should complete the execution in slightly over 3 seconds. Now, to execute this task, I call the first function task A and pass an anonymous function as a callback that accepts one parameter. Now, the callback function of task A, when it executes, it calls the task B, and while calling task B, it passes on the string task A output as the first parameter, and the second parameter gets another anonymous callback function. Now when the callback of task B executes, it calls the task C, and here too it passes the string as the first parameter and an anonymous callback function as the second one. Now in the final call of the task C, it sends the console.logs function as a callback to print the string. Now looking at this code, it is not very easy to understand how these callbacks are cascaded. At least it took me a little while to grasp this code and come up with the explanation which I just shared with you guys. Now we will see how promise simplifies this code. And to make these task functions work with the promise, I have made some changes in the code. The first function task A now will be an executor function, and it accepts two parameters, resolve and reject. Now in the set timeout function, I call the resolve instead of callback function with the data that I want to pass on to the consumer, which is the .then method. The second function, task B1, executes synchronous code, so it does not need a promise constructor. Now with the return statement, JavaScript implicitly wraps this as a resolved promise object and passes it to the next consumer. The third function, task C1, again executes a synchronous code, so it has to return a promise object. And once the resolve function executes, it returns a promise object to the next consumer. So whenever I have to execute asynchronous code, I have to put it under the promise construct. And when the asynchronous code finishes execution, the resolve or reject method returns a new promise object. Finally, I add one more function with a console.log statement to print the input it receives. Now to execute this code, I create a new promise object and pass task A1 as a callback. This is the executor function passed to the promise constructor. Once the asynchronous code executes, I grab the promise object and start with the promise chain. It then calls the task B1, which concatenates the input received with its value and returns it. Now remember, this is a synchronous code, so JavaScript implicitly wraps it as a resolved promise object. This is followed by task C1, and this asynchronously concatenates the data and returns a promise object. Finally, the show output function displays the data. Now if we compare the two code segments executing these tasks, it is very clear that promise keeps its promise quite well and makes the execution look like a sequential task, which is easy to understand. Now consider a situation where I have to add a new task between the task B and task C. It is much easier with the promise. Now before we move ahead, let's look at one more example. I took this from the previous video of callbacks. Now in this, I read data from 3 files. I accumulate the data and then write the data in the 4th file. All the operations are asynchronous, which created this callback hell. I wrote the code again to work with promise. The first function is an executor function, which I pass to the promise constructor. Now the function reads the file in asynchronous mode and the read file function is asynchronous. The second function 2 reads the file in asynchronous mode and returns a new promise object once the read file operation is complete. The third function reads the file in synchronous mode, which reads the data and returns it. And the final function of writing the data is also synchronous operation that writes the data to a new file. So once I have the promise object, after reading the data from the first file, I start with the promise chain and read the second file, which returns a new promise object. The next step in the promise chain is read the third file and return its content. And the final step in the promise chain is to write the content in a new file. Again, if we compare the two code styles, promise is indeed promising. Now we will learn about two more consumers, .catch and .finally. Starting with .catch, so when a promise is resolved or settled as rejected, it calls the reject method with an error message. The .catch method is used to manage the error situation. Now just like .then, this too returns a new promise object. Internally, .catch invokes the .then method and passes the argument it receives as a second argument to the .then method. This segregation of program logic from error handling makes the code very easy to understand. Coming to the next, finally, now this method is called regardless of the state of a promise. This too accepts a callback and that receives no parameters, and the callback should not return anything. In case it does, it is ignored. Now let's see the implementation with the help of an example. In this code snippet, I wrote an executor function that calls the reject method. I also wrote two more functions, show success message and show error message with a console.log statement. Now in this example, we will see how to use .then method to manage both success and failure of a promise object. So I passed both the functions, show success message and show error message to the .then method. And since the executor function has executed the reject method, the function show error message executes. Now I will show how to use a .catch method. Now in this case, I pass the function show success message to the .then method and show error message to the .catch method. Now since the executor has executed the reject method, the control directly goes to the .catch method, skipping the .then method, showing the error message. Now we will look at the .finally method. We can simply add this to the promise chain at the end and it executes irrespective of the state of the executor function. With this, I conclude this video, and in the next video we will learn about async await. Let's summarize what we have learned today. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.